If you always try to find a performance engineering solution that will fully integrate with your observability backend, then this episode is for you. Welcome to Is It Observable? The main objective of Is It Observable is to provide tutorials on how to observe a given technology. Today's episode is part of an existing series, the SREs, where we already covered several topics such as the introduction to SLI and SLO, what is chaos engineering, and we had a dedicated episode related to Litmus. And recently, we had an episode on what is performance engineering. Today's episode, we will focus on one of the load and performance testing platform named K6. If you're looking for content dedicated for performance engineering or load testing, I would definitely recommend to watch the YouTube channel named PerfBytes. This episode will introduce to K6 and few extensions that I have personally used. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you're going to learn out of this episode. We will start with a brief introduction on the K6 solution and also describing the architecture. Then we will explain how to build a test case with K6. Then I will present few useful extensions for our observability backend. And last, as usual, we will jump into a tutorial. K6 is a package that you can either install in a bare metal environment, so Windows, Linux, and macOS, and also in a containerized environment with the help of the official Docker image provided by the Grafana K6 team. The K6 client is, in fact, a command line, allowing you to generate a high number of virtual users directly from the client. So K6 by default won't allow you to run distributed tests utilizing several load generators. It means that K6 client acts as a controller component orchestrating the test and a load generator, so a component sending the traffic to your application. The open source solution of K6 is not providing any UI or utility to analyze. That is the reason why there are a large number of extensions that will help us to store the load testing statistics into an external storage, like InfluxDB, Prometheus, and others. K6 offers a SaaS solution named K6 Cloud. K6 Cloud provides a web UI helping us to design, to run, to schedule our tests using several load generators. So K6 Cloud allows us to run distributed tests. K6 solution supports out-of-the-box couple of protocols. We have the HTTP, so HTTP 1.1 and 2, gRPC, and WebSocket. But K6 has a lot of extensions, so you can still extend the capacity of a K6 by utilizing one of the existing extensions that will help you to add extra protocols. So there are extensions that will help you to generate stress on your database. There is extensions for MQTT, browser-based. So in the browser-based extensions is basically driving a headless browser. You have IMQP, Kafka, and more. K6 relies on a script defined in JavaScript using the K6 library. The K6 open source does not have any recorder. So the idea is that you will have to define the workflow of requests that will help you to reproduce the real end user traffic. To start building your test case, you will need to first import the right library. So here we import the library allowing you to interact with the HTTP protocol. Here is a library for gRPC. And last, here is the library for WebSocket. So once you have imported the right library, you will be able to create requests using, in the case of HTTP, http.get or http.post and many others. In the case of gRPC, we have to, of course, to initialize our gRPC client like this, and then we can interact with one of the RPC endpoints of our API. In the case of HTTP, The request can have several properties. We can name a transaction, we can precise the expected response code. If you don't, K6 will check that the response code is lower than 302. You can also tag your traffic to group all the requests generated into one statistics. For example, if we do product/jeans or product/NID, at the end all the request is about looking at the product. So we can name that, let's say, a tag called product/product ID. And all the statistics will be then merged into that name. If a transaction is combined of several requests, you have the options to create a group of requests, and that will be a transaction. So here is an example. So as you can see, we create a group called visit product listing page, and within that function, we can add all the requests that we need for that particular transaction. When running your K6 test, it is also important to validate that the application is generating the expected responses. For that, K6 provides a library called check that will help us to validate our responses. For example, so here we have an example. So we send an HTTP GET request to an endpoint, and then we define the check. The check will be basically on the responses of our HTTP request. So the check allows us to check, for example, the status code. We can also apply checks on the content of the response using the response body, and then we can have includes or excludes rules. We can also check the response size of our HTTP request or gRPC by using the response body length. When designing your load test scenario, it's really important to properly correlate your tests to make it realistic. This is why you probably need to extract content from the response, like the product ID, for example. So the correlation mechanism can easily be done by applying a regexp or JSON path or whatever you want in the response body content. The K6 test has a specific structure. So here is the exact structure. You can see that the first section is to init, where we precise the library that we would like to use by having import. And then we can define global variables and settings for the test with the help of the option objects. The setup is optional. It's basically all the steps that you would like to execute before the execution of your test. And basically you can build some data, initialize some variables, and then they will be used for the execution of your test. Default is the actual test. So at the end, default will be the part of the code that will be iterated on and on until the end of the test. Tear down, it's basically optional as well. This is the part that will be executed at the end of the test, just before the end of the user. Option. The option object will hold all the information related to our test. For example, how many users, how to ramp up, the duration of our tests, how to ramp down. We can also define some threshold as well. For example, you can see we can define the host, we can define the actual duration for each part of our test. We can also define thresholds on how we could validate our tests, and so on and so forth. Thresholds. K6 allows us to define targets our test by defining thresholds on the statistics. The threshold will need to be defined in the option object. So for example, here we have an example of thresholds where we define a new threshold called HTTP request failed, and we define the rate. Same thing for the request duration. Metrics. K6 allows us to create metrics that we could report at the end of our tests. K6 has several types of metric type. Similar to Prometheus, we have the gauge, we have rate, we have counters, and we have trends. You will need to define in the init the metric type that you would like to build, and then in the actual script, so the default part, you will add values into your metric that you've defined. To run a test, With K6, it's very simple. You will just need to use the command K6 run, and you'll precise the name of your script. Report and results. K6 will generate by default a summary report displayed in the output of your test, in the stdout. You can also specify the output that you want to use. You can generate a JSON file containing all the data points of your test with the options -out JSON. Or you can also use any output extensions available in the community to push at the end the statistics generated by K6 to an external storage. The beauty of K6 is the large number of extensions. All the extensions are currently listed in the following website. K6 has built an XK6 tool that helps us to build our K6 client by adding extensions. So for example, if we want to build our new customized K6 client, we can use that command by precising that we have a module that we want to add. There are different types of extensions that will, for example, extend K6 with extra protocols. So we have plugins like XK6 AMQP that adds the AMQP protocols, the XK6 browser to add a browser-based test, XK6 Kafka could generate load against your Kafka instances. We have the XK6 Redis to test your Redis database, XK6 SQL, SSH, Storm, TCP, and there are many extensions of that type. Then you have extensions that will help you to build your test case. For example, library to parse URLs, so the XK6 URL to helping you to parse URLs, the XK6 YAML to encode or decode YAML values. You can also XK6 NATs to provide a NAT support, and there are plenty of them. Then there is extensions that will help us to push the results to an external storage. So it's an output extensions. So we have the Amazon CloudWatch, the CSV, Datadog, of course, Grafana Cloud, InfluxDB, New Relic, Prometheus, StatD, and way more. K6 provide also, from my perspective, an amazing plugin called XK6 Distributed Tracing. That extension will basically create the first OpenTelemetry spans from the K6 client. So if you're planning to test any solution producing OpenTelemetry measurement, then this plugin will be very helpful. There's also another extension that I really like because I try to do things related to Kubernetes, and it's the K6 operator. That extension allows us to run distributed tests, K6 tests of course, in our Kubernetes cluster. The operator adds a new CRD called K6. That K6 will hold all the settings to run a test. So here is an example of a K6 definition object. You can see that you can precise the name, the script, and you can see the script will be stored into a config map. You can also define how many parallelism you want to have, your custom image of K6. In the case you have added new extensions, you will add them there as well. There's another interesting plugin that interacts with Prometheus. In fact, there are two plugins related to Prometheus. There is the XK6 Output Prometheus Remote. So this extension is the official one provided by K6, and it will basically interact and write the K6 statistics into your remote Prometheus server. In fact, this extension uses one of the features provided by Prometheus called Remote Writer. If you want to utilize this plugin, you will have to enable this feature on your Prometheus server. There's another extension. So here is the URL. This extension is built by the community. This plugin is a bit different because K6 becomes a Prometheus exporter and exposes statistics on a specific HTTP port and in a specific HTTP path. In this tutorial, we will deploy the K6 operator in our Kubernetes cluster. We will also generate a custom K6 image with a couple of extensions pre-installed. We will install the Prometheus extensions and the distributed traces extension as well. So we will have several requirements. So first, like usual, we will need a Kubernetes cluster. We will deploy the nginx ingress controller. We will have to configure a couple of ingress roles to expose the demo application. So we will have to, of course, deploy this demo application, which is the HipTheShop, like usual. We will need to deploy the K6 operator. And because we're going to generate some OpenTelemetry distributed traces, we will deploy the OpenTelemetry operator. We will explain the script that will interact with the HipTheShop. We will deploy the Prometheus operator. We will create the right ingress rule to expose Grafana and of course the HipTheShop. We also configure Prometheus to enable the remote writer feature that is required by K6. We run a small test and look at the results in Grafana.
Like every tutorials that we deliver in Is It Observable, there's always a GitHub repository related to the episode. So here we're looking at the episode related to K6 because it's the K6 episode, obviously. A couple of things, like explained, we're going to deploy several things. I'm not going to go through all the steps to deploy all the stack because there's a lot of components. I want to mainly focus on the K6 side. Like usual, there are a couple of components required to run those different deployment scripts. So Helm, if you use Google Cloud, you're free to use all the stuff, of course. If you use Google Cloud, it will be better to get the Google Cloud clients, kubectl, Git, of course. And then to deploy the operator, you will see there are a few requirements to deploy the K6 operator. So we need the Go runtime will be required in any case, GCC, and customize. So make sure that you have those deployed in your environment, otherwise you will run into errors. Then later on in these tutorials, we will run different type of tests. One would be traditional HTTP end-to-end test. And we have another type of test, which is, we'll call it the technical dev test. It's a component level testing, interacting with the microservices of the HipTheShop. And those microservices are basically interacting with gRPC protocols. We will basically design a gRPC test. And this, you'll see there is a couple of extra files. And to be able to use the operator, you will have to create an archive. And K6 command line has an archive options to help you to build that archive with all the required files for the test. So make sure K6 client is installed, because at the end we will create that archive and one of the steps to be able to run this component level testing. Like explained, make sure you deploy you have of course a cluster, you deploy ingress, get the IP address, because several files will be updated because they're referring to this IP address. So of course, the HipTheShop ingress rule, the Grafana ingress rule, and then the various load tests pointing to those endpoints. Like usual, we'll deploy Prometheus. And because in one of those tests that we're going to run, we will interact with one of the plugin called the Prometheus Output Remote Writer. It will be required to be able to take advantage of that feature to enable the remote writer feature in Prometheus. So make sure you update your Prometheus settings, so through the Prometheus objects, to enable that feature. Then we're going to produce traces. So to make it simpler for the deployment, we're going to deploy the operator, the OpenTelemetry operator. So this is the standard steps to do so. And those traces will be ingested in Dynatrace. So that's why you need a couple of components for Dynatrace. The first thing, if you don't have any Dynatrace tenants, no big deal. You can go to dynatrace.com/trial, and here you can basically request for a new trial. Once you get the new trial, you will get your Dynatrace environment. And this Dynatrace environment, before you do anything, we will need a couple of things to do that. We need your Dynatrace tenant URL. So the first piece, just before HTTPS and to .com, is going to be the environment URL. So we make sure that you just copy that part. Because we're going to interact with several APIs and several concepts of Dynatrace, you need to have the right access token, because we're going to deploy not the agents, because we rely on OpenTelemetry, but we need at least an active gate. To deploy this active gates in the cluster, there are a few things. So first, there is the easy way of doing it. So you can do it on deploy Dynatrace. So that's the menu. So this is not the steps I have described, but you keep in mind you can do it that way. So deploy Dynatrace, click on install active gates. That's what we're looking for. Kubernetes, and here we will have a wizard that help us to deploy it. So you can see we can generate the token. It will create the token with the right scope that is required. Same thing for the data ingest. So make sure you name and so on. Skip the SSL certificate. We don't need that. And then you will see we'll apply that. So that's the, I would say, the wizard approach, followed by Dynatrace. But if you want to follow the steps that I've described in my tutorial, you will have in this case go to access token. So access token, as you can see, it relies on 2 tokens. So we'll have to create 2 distinct tokens. One will be, let's say, token. Let's say call it token for operator. Let's say token for operator. And then here you will select specific rights. So we need, for this token operator, we need to be able to read configuration. So type read configuration, and you can we'll have select this one. We will also write configuration. So write configuration, here it is. And then same thing, we will have to write settings and read settings. So we're going to click on write settings and read settings as well. So this is the rights. And last thing is, because we were going to create new entities in Dynatrace, we need to be able to read those entities and also to write those entities. So those are the various things. And then last, because we're going to install things in the cluster, we need to be able to install downloader, so have that right. And we are be able probably to create problems. So you search for problems, and here you have a specific right for access problems, event feed, metrics, and topology. So that's the right for the operator. The second token, so make sure to create that token and copy the value somewhere, because we need that value later on. But there is another token that we need. It's the Dynatrace token for data ingest. And if we do this, you will have 2 rights. We're going to ingest metrics. So if you click a search for ingest, we're going to ingest metrics from a K6 perspective and from an OpenTelemetry perspective. And also we're going to ingest OpenTelemetry traces. So those are the 2 rights that we need, at least for our use case. You can also click on ingest events. That could be also great for the community's perspective. So that's typically the main rights that is required. So one for the data ingest and one for the operator. So once you have the token, like I said, copy that value somewhere and keep it somewhere. So you need the API token for the operator, the one for the API token for ingest. And then those will be basically required to update the Dynacube. So Dynacube is the new CRD that helps Dynatrace to be deployed in your cluster. So you need all those different various informations. And then you can see here, it's the traditional steps that we saw in the wizard that will be deployed. So the creation of the namespace and the deployment of the Dynacube and so on. Once we have this, there are other files that relies on the Dynatrace settings. So we need to update OpenTelemetry operators. So with the Dynatrace tenant URL, because we're going to export traces and metrics there. So make sure to update this one. Same thing, I've built an experimental plugin extensions for K6 for Dynatrace, and we're going to use this one. So we need obviously to update also those tests to be able to point to our Dynatrace tenants. Same thing with the token, of course. We need to replace the token for OpenTelemetry operator and the various K6 tests. Last, we need a cluster ID, and we're going to replace it for the OpenTelemetry collector pipeline. All right, so that's the most requirements. And last thing that you will need to do by yourself is to deploy the operator. This basically is coming from directly the Git Grafana repo for K6 operator. So the steps is very simple. You need to clone this repo, make deploy, and make install. So that will install everything required, and then you will be able to run the test that I have. So what you get once you have everything deployed. So let's have a look at our cluster. So if I do kubectl get pods minus Dynatrace in the Dynatrace namespace, you will have 3 pods running. One is the active gate deployed, and the 2 other ones, the operator is there to basically make sure to change the deployments through the definition that we have described in the Dynacube. So this will be required in webhook. In our case, we don't need it much because we have no agents that will be deployed, but it's there from the Dynatrace stack at least. Second thing we're going to look at is there's another namespace created for this tutorial called the K6 operator system that basically hosts the operator itself. So there is 2 containers. One is the airbag proxy, and the second one is the manager. So basically taking our new K6 CRDs and running those officially those tests in new pods. All right, so let's have a look at the various K6 tests. First, start with a traditional, let's say, HTTP test. So if I open, we have a K6 test that will basically interact with the Hipster shop. So a few things here. First, you can see that we have the import. So we have importing HTTP because we use HTTP. I have imported the check and sleep to make some pause. And we can also report few counters related to the test itself. As you remember, here we have the URL to our environment. So make sure to replace, like I said, the IP for your environment. So as you can see, nothing is very fancy. It's just a couple of loops. So in the default, which is our test here, we can see that we have a for because we have a couple of tables like tasks. So we want to go to index, to currency, to browser. So this is the various steps various page we want to browse into. So we're going to get those pages and check the status that is working well. In case of problems, we will report errors, and then we make a pause to do some think time to wait few seconds. Once we have this, we can go to the currency page, change the currency. We do the same thing for browsing a page. So here we have a table with some products. So we select randomly one of the product and we'll go for it. Then we can add some product in the cart and then we submit. So you can see we mainly rely on the HTTP K6 method to add the various properties. And then we use the check to validate that the status code is expected, or you can also do some checks on the response. The other test that I mentioned is the component level testing. In the component level testing is a bit different because we are using gRPC. So we need, of course, to import gRPC library here, like expected. And you can see that we have the options to define how many users we want and how long we want to run that test. And then you can see that the gRPC approach is a bit different. So you need first to load the definitions of your RPC calls. So you need to have a folder with those. So I have a proto folder with the demo.proto file, and this is basically coming from the official Hipster Shop source code. So it's basically the definition of the various RPC or services using gRPC. So you need it. You need that definition because it's need to be loaded to be able to interact. So the first piece is create the gRPC client, load the proto files, and then we can start. So we can start connecting in our case, to the product catalog services, which is in the Hipster Shop service namespace. And then basically we list the product, and then we basically pick one of the product, and we basically look at the product in details. So I have got two examples. So let me bring the source code. In the K6 folder, there's a lot of things, and there is Docker files and Docker file prom. So the first Docker files prom is basically here explaining how you can build those images. At the end here, I'm using just a gold-length standard image, and I'm installing the XK6 image utility. And this one is very important because we will rely on this one to be able to build the new K6 command line, including various modules. Like explained here, to be able to create a K6 including new extensions, you will have to use the XK6 build. You define where you want to generate that command line, and of course you can add as many extensions as you want. So here I'm using the XK6 Prometheus, the K6 distributed traces. In fact, I have slightly changed a bit. This one is not the official plugin from a K6 perspective. It's the one that just exposes data in a Prometheus format. This plugin has the advantage of exposing, creating an exporter with the data, but you will see that there is less dimensions. So it's very hard to build properly a precise reporting on what is slowing down, which request, and so on. So I won't recommend to use this one. I would recommend, in fact, to use the other one, the official Prometheus remote output plugin, which is here. This is the one. So if you want to use it, make sure to add this one. By the way, in fact, I'm going to change it. So then you will have this instead of the other one. And then once we have created the K6 library, then I'm collecting the latest version of K6 client from the load impact repo. I'm pretty sure that it's also in the Grafana repo. And then basically I copy and replace the K6 command line by the one that we just built it. So it's going to be the traditional K6 client plus on top of that the various plugins used. So here I have also created an experimental K6 Dynatrace output that we're going to use. So here is how you can build it. I also have added this Docker file here in this repo. So you can see the same approach. I am here, and the difference is that I'm referring to the code, so it's including the code and compiling it, and also adding the K6 distributed tracing. So both works pretty well. The K6 CRD, I have three objects in this repo. I have the K6 load test, K6 prom distributed load test, and K6 component. So K6 load test is going to be end-to-end test using the Dynatrace extension. K6 load test -prom _ distributed is using the Prometheus output remote and the distributed tracing extension. And then last, we have K6 component using only Dynatrace, and it's interacting on the gRPC level. So let's have a look at the various CRDs, starting with the component level. So you can see in the component level, first there is a K6 object. Now you can see you will give a name to that specific test. You specify how many concurrent load generators you want. Like here it's only one, but if you want to have 3 or 4, you can increase the number here. And then you need to refer where is located your script. As you can see, I have a config map called K6 test, and here we are referring to the archive. So I'm going to show you briefly how you can build that archive using the K6 client. Then arguments, this is where you precise what you enabled, if you have extensions or even change some settings. In my case, I just use the output Dynatrace, the extensions that is experimental. And then there's 2 objects, the starter and the runner. So the starter is the first object to be launched, and then the actual test will be in the runner. So the starter, if you need to do some data creation, whatever, you can put it separately. But the runner will be obviously where you will have your main test. So here you can see I'm using a specific Docker image that is K6 plus Dynatrace output, and I need to specify a few variables. So the Dynatrace URL, with you need to replace your tenant here, the Dynatrace token, so with the right token here. And last, if you want to use the external tracing, you need also to precise the OpenTelemetry collector address where you can push those spans. I was mentioning that you need to create the archive, so let me show you how you do that. So first you need to go to the right directory. As you can see here, we are at a folder containing all the various information of our tutorial, and I'm going to jump into the K6 folder that has our component level test. In this in my Windows machine, I have the K6 client. So if I create K6, you see it's going to interact and show me various options with the command line. But to create the archive, there is an archive command. So if you do K6 archive, and then you precise the script that you want to, where you would like to build this archive. In my case, it's the component level testing. By doing this, K6 is basically creating the archive, the tar file, in fact, with all the required files. So it's going to go through the JavaScript in our case, and because we were, in the case of gRPC, we are relying on the proto folder, it will naturally include the proto folder as well. So then with this archive, K6 will have everything required to be able to run your gRPC test. Now, let's have a look at the other object. So we have now the K6 load test. This is the traditional one using, again, the Dynatrace output plugin. So it's similar settings. The main difference, I have added 2 parallel executions with another name. Then we have create a similar one, but slightly different. Why slightly different? Because here I'm in basically pushing the data to Prometheus remote writer plugin. As you can see, it's been enabled here. I don't have the same image anymore. I'm using another type of image to do this. That includes K6 plus the Prometheus remote plug extension. And as you can see, also the script itself has changed. Why? Simply because I'm using the X-distributed tracing extensions. The idea, when you use the X-distributed tracing extensions, you will have to remove the traditional K6 library in your script and import the tracing library provided by the new extensions. And these extensions have a new HTTP objects that you will have to initialize at the beginning of your scripts. So if you scroll down here, in the beginning of the actual script, which is the default functions, you can see I'm creating and initializing the HTTP object, which is in fact the tracing object, where you define what is the format of the exporter, in my case OpenTelemetry, what are the propagators, and then if you have an exporter, in my case I basically push the URL to that exporter. As you saw, we are referring to a couple of config map that hold basically our scripts. The first holding all the end-to-end tests, so load generator scripts with the Dynatrace and the other one with just Prometheus. I will have the component level testing that will be created through the archive that we just did a few minutes ago. This will be deployed in the Hipster shop because it's basically interacting with the services in that Hipster shop folder. So let's first create the namespace K6, which I already done. So make sure you create it, and then let's create the config map. So I'm going to create one config map that is basically K6 test, the one that we're referring in our K6 objects, with one file, the K6 load generator, and the other one, load generator distribute tracing. So those are the 2 ones. Then we need to create the other config map on the Hipster shop namespace. That will basically store our gRPC test with all the various files. So let me create this one. So Hipster shop config map has been created. So both things are ready. Let's start running the first test with the component level testing. So in the Hipster shop namespace. All right. And now let's have a look at the pods running in that Hipster namespace. So as you can see here, we have a component level testing that is currently running. So if you want to check out the logs, as I can see here, I have a couple of things generated by the client, so I can see that it's currently working. And let me check in my Dynatrace tenant. I should have some metrics. Data Explorer will be easier. So case 6. As you can see, we have a couple of data coming in already from K6 perspective. So I can look at the VU max running and so on. So you can see here we have 30 virtual users. That's the one we're currently running. So we have data coming in Dynatrace. All the data that comes from K6 will come from K6 dot. So if I use K6 dot here, you can see now we have the gRPC request metrics coming in. Let's jump into the next test and run instead of the K6. So now it's currently running. You can see it's running, but now we can still also, I'm able to run another test. So let me run. So the load test has been created. So that's similar. I'm going to look at the pods running in that namespace. And I can see I have two pod running on the last. As you can see, it's currently running and using the Dynatrace output plugin. So let's have a look at the Dynatrace now. So if we go back here and do type K6 again, and I dot, and I will have in a few seconds other metrics, so we can still wait a few seconds. A new tests coming in soon, so that's why we have different more and more users here, and here coming in. You can see here we start to have more metrics. So we have the request per second, the request waiting, the handshake, the request sending, receiving, and of course we have the duration. So if I click on duration, I click, so here I have the average duration for a specific request. But the good news is that we have the errors listed, we have the status, we have lots of dimensions, and the one we could probably be interested is URL. So if I look at URL, I can see all the various URL that we have sent. Same thing, I'm going to use again. All right, so now it's been created. So if I do look at the pods, I have the new one running. So if I look at the new one running, as you can see, it's using the Prometheus remote write output and also the other one. So we should have data coming in there. Grafana now. All right. And now if I explore the data, I can basically browse here. I can not low-key, of course, but Prometheus. I would be able, for example, to look at the metrics. So if I type K6, I should have some data. So you can see here the data is also coming in K6 from in Prometheus. And you can see we have this similar data that we have. So the data we saw in a few seconds ago in Dynatrace will be the similar one in Prometheus, but you can basically do the PromQL instead of using Dynatrace in this case. So here we are. So we have K6 traces here, so you can click on K6. And I can filter, so you can see here we have get, we have different requests here, so I can click on one of those requests. All the post and get requests are there, so I can click on get here. And as you can see, you will see that you could be then troubleshoot and understand what is spending time in this specific transaction by looking at the various spans produced by OpenTelemetry.
That's it for today's episode related to K6. As you can see, K6 provides a couple of interesting features, especially all the large number of extensions make K6 very powerful in terms of design, of course, but more on the output side. I really like the fact that we can basically generate distributed traces, that we can easily export our statistics into many different storage like InfluxDB, Prometheus, and many others. So it's very promising. The only missing part is the fact that there is no recorder, so we have to build our workflow of requests. But again, if you do component level testing, K6 is perfect for that because at the end you don't need specifically a recorder. If you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode. Bye.